Black holes are the universe's ultimate traps. They are famous for one thing. Once you cross the point of no return, you're gone. But here's the twist. You don't have to fall in to die. In fact, a black hole can kill you from a safe distance, long before you ever reach its horizon. We usually think of black holes as cosmic vacuum cleaners, sucking in everything around them. But the reality is much more terrifying. Even approaching one is a deadly game. Today, we are going to explore the many ways a black hole can end your existence, starting from the outer edges of its influence all the way to the singularity. And spoiler alert, the journey kills you long before the final plunge. The first line of death. Let's start at the outskirts. Imagine a black hole that is actively feeding. It has a swirling disk of gas and dust around it, called an accretion disk. This disk is heated to millions of degrees by friction and gravitational energy. It glows across the electromagnetic spectrum: X-rays, gamma rays, ultraviolet. If you got anywhere near this disk, you would be fried. The radiation would be so intense that it would strip the electrons from your atoms, turning your body into ionized plasma long before you felt any tidal forces. It's like flying into a nuclear explosion. But what about a quiet black hole, one that isn't feeding? Those are harder to detect, but they are still surrounded by particles, the thin gas of interstellar medium falling inward. That gas gets accelerated to near light speed and emits high-energy radiation. So even a dormant black hole has a deadly glow. Your first warning might be a lethal dose of X-rays that leaves you with radiation sickness within minutes. Stretching from afar. Okay, suppose you somehow shield yourself from radiation. You approach a supermassive black hole, like the one at the center of our galaxy, Sagittarius A star. These giants are millions of times the mass of the Sun. Their gravity is immense, but their tidal forces near the event horizon are surprisingly gentle because the horizon is so large. However, as you get closer, you'll start to feel a stretch. Gravity pulls stronger on the part of you that's closer to the black hole. This difference in force across your body is called a tidal force. For a supermassive black hole, you might cross the event horizon without even noticing a stretch. But for a smaller black hole, say a stellar mass black hole, just a few times the mass of the Sun, the tidal forces are brutal. Even tens of kilometers away from a stellar mass black hole, the difference in gravity between your head and your feet would be enough to rip you apart. This process is called spaghettification. You become a stream of atoms, stretched into a long, thin strand. But notice, this happens before you even reach the horizon. So yes, a black hole can kill you from a distance simply by pulling you apart with gravity. Grinding and heat. Now let's talk about the accretion disk again, but from a mechanical perspective. The disk isn't just hot, it's also a chaotic mess of gas and dust moving at relativistic speeds. If you were falling toward the black hole, you'd have to cross through this disk. Even if you avoided the radiation, the material in the disk is like a high-speed blender. You'd be hit by particles moving at a significant fraction of the speed of light. Collisions at those speeds would vaporize you instantly. Think of it as the difference between standing in a gentle rain and being shot by 1 billion bullets per second. That's the accretion disk. And because of friction and magnetic fields, the inner parts of the disk are also where jets form, powerful beams of plasma shooting out from the black hole's poles. If you happen to be in the path of one of those jets, you'd be incinerated from a distance of light years. The point of no return. Let's say you survive all that. You're falling toward a supermassive black hole. You cross the event horizon, the boundary beyond which nothing, not even light, can escape. But here's the thing. From the perspective of an outside observer, you never actually cross it. You slow down, fade, and redshift into nothingness. That's the classical picture, but from your own perspective, you cross the horizon in finite time. Now, what kills you? For a supermassive black hole, tidal forces inside are still small. You could theoretically pass the horizon intact, but there's another effect: time dilation. As you approach the horizon, time for you slows down relative to the rest of the universe. But that's not lethal in itself. What might be lethal is the firewall. Some physicists propose that quantum effects at the horizon create a wall of intense energy, a firewall that would incinerate anything trying to enter. This is a controversial idea, but if it's true, you'd be vaporized at the very threshold of the black hole. So even if you got that far, the horizon itself could be your executioner. The road to the singularity. Assuming you pass the horizon without a firewall, you now fall inward. The interior of a black hole is not empty space. It's a region where space and time swap roles. The singularity, the point of infinite density, lies in your future. You can't avoid it. As you approach the singularity, tidal forces become infinite. For a supermassive black hole, you might have hours or even days before you reach the singularity. But as you get close, the stretch becomes unbearable. Every atom in your body is pulled along different paths. Your molecules are torn apart. Your atoms themselves are ripped into subatomic particles. Eventually, you are compressed into the singularity. So even if you survived the journey in, the singularity is the final killer. But the question of the script is before you fall in. So we've covered that the journey can kill you well before you get to the singularity. Could you survive? There is a strange exception. If the black hole is rotating, and all real black holes rotate, the interior is different. There's a theoretical possibility of avoiding the singularity if you go through the ring singularity in a Kerr black hole. Some solutions suggest you might emerge into another universe or a different part of space-time. But that's pure speculation. Even in that case, you'd be killed by the tidal forces or radiation long before you got that chance. The idea of surviving a black hole is purely mathematical. In reality, any physical object, especially a fragile human, would be destroyed. Another concept, what about a black hole so massive, like 1 billion solar masses, that tidal forces at the horizon are weaker than those on Earth? You could cross the horizon without feeling a stretch, but you'd still have to deal with radiation from infalling matter, and eventually the interior crunch. So, survival is unlikely. Can a black hole kill you before you fall in? So, let's answer the central question. A black hole doesn't need you to cross its horizon to end your life. The moment you enter its sphere of influence, you're in a deadly game. If it's an active black hole, the radiation from the accretion disk will fry you from a distance, delivering a lethal dose of X-rays and gamma rays long before you even see the horizon. If the black hole is smaller, tidal forces will stretch and rip you apart tens of kilometers away. Spaghettification that turns you into a stream of atoms well outside the point of no return. And even if you somehow avoid radiation and spaghettification, the accretion disk itself acts as a cosmic blender, vaporizing you with particles moving at near light speed. If you're unlucky enough to be in the path of a relativistic jet, you'd be incinerated from light years away. Then there are the more speculative dangers. Quantum firewalls at the horizon that could instantly burn you to nothing, and the relentless time dilation that, while not lethal on its own, seals your fate. In short, a black hole is not a trap that only kills you once you're inside. It is a zone of death that extends far beyond its event horizon, offering countless ways to destroy you from a safe distance. The only way to survive an encounter with a black hole is to stay very, very far away. So, why do we spend so much time studying these cosmic executioners? Because black holes are nature's most extreme laboratories. They push our understanding of gravity, quantum mechanics, and the very fabric of space and time to its limits. Every way they can kill us teaches us something new about the laws of physics. If you had to choose, would you rather approach a small, stellar mass black hole for a quick spaghettification, or take your chances with a supermassive giant to see what lies beyond the horizon? Let me know in the comments. Thanks for watching Daily Dose of Space. Stay curious, and I'll see you tomorrow.